Hello, welcome back to Every Problem. This is Stewart Calculus 8th edition, section 1.4, problem 20. So problem 20, I think, is a little bit easier than 19. 19 had a bit of thinking to go with it, but for 20, we need to find the domain of the function. So for part A, we have square root of 10 to the t minus 100. Well, we know that 10 to the t needs to be greater than equal to 100 all the time. Otherwise, we have some negative number underneath the square root, and we cannot have that. That's not good. So 10 to what power, right, is going to be greater than or equal to 100? Well, we know that 10 squared is greater than or equal to 100 because it is 100. So we know that t must be greater than or equal to 2. So for this function, we'll just say domain, and the domain is going to be closed bracket 2, comma, infinity, open bracket. And that's because it can include 2 exactly, but we can't close off infinity, so we need to leave that open. Now for part B, g of t equals sine e to the t minus 1. Well, luckily for us, sine is a continuous function. Continuous meaning that there are no interrupted intervals. Sine has an unlimited domain, really, and there's no real input that you could put for sine that gives you some non-answer. So that's good news, because as long as e to the t is defined on all intervals, then sine will also be defined on all intervals. And we know that e to the t is a continuous function. So if e to the t is a continuous function and e to the t is embedded within sine, then that means that both of the functions, right, when you compose them, they will be continuous so long as their domains match up. So e to the t's domain is all real numbers, and sine's domain is all real numbers. So if you compose sine with some form of e to the t, as long as there's no dividing by 0 or anything, then your domain will also be all real numbers. So your domain will end up being negative infinity to positive infinity. And that's going to be your answer for problem number, is this 19? No, this is 20 for problem number 20.